Hello everyone, warm greetings from Dubai. Welcome to the DevOps Institute Skill Up Days on Observability. Today I'm going to be talking about AIOps and how AIOps can be used to derive much more meaningful insights on observable data. We will also look at how critical information from DevSecOps can be used to predict resiliency and how feedback from incidents can be used to shift left quality in DevSecOps. So my name is Shivagami Gugan. I'm a technology transformation leader, specializing in aviation technologies. So I headed software engineering at Emirates Group for a number of years and delivered mission critical software. I also led digitization initiatives, DevSecOps, SRE, cloud transformation programs for large organizations. So I'm a DevOps Institute ambassador, and I'm the chief technologist for Middle East and Africa at AWS. So a few takeaways from today. So we're going to very little look at data ops because clean data is essential for AI models, and so how data quality impacts these AI models. So data is core to observability and AI ops. We're also going to look at maximizing the potential of observability with AI ops, which is the core topic. How can we use ML capabilities in AI ops for speedy resolution, speedy detection, how to crash MTTD, right? Mean time to detect even if there is a manual intervention. And how do we feed forward information from DevSecOps? So firstly, why AI ops? So there is this law called the law of requisite variety, which means that if a system has to be stable, the number of states that you use for controlling it, for example, in this case, observability, must be greater than or equal to at least the number of states in the system being controlled. I mean, and we're talking about complexity, right? We're talking about complexity, we're talking about transients, we're talking about distributed ecosystem. So observability features microservices architectures, distributed infrastructure. So it becomes very difficult to pinpoint the source of a problem and to take steps to increase the observability on applications and on the supporting infrastructure. So observability provides metrics to understand what, where, why issues are happening. Now AIOps gives further meaning. It augments when we actually apply it on observable data. When observability data is fed into AIOps, the correlation of events, the ability to identify problems using ML capabilities becomes much, much higher. So through the detection of anomalies, to the identification of location, cause of incidents, suggesting even fixes, AIOps suppresses incident noise and alerts so that we can actually work on attention can be spent on valuable uh, incidents, and we don't have to be disturbed by false alerts, for example, right? There will be 40% of the teams who will use AI augmentation in large enterprises, and this will result in higher productivity. This is because of the multi-cloud environment. This is because the sheer volume of data is something that it is impossible for humans to monitor, comprehend, and take action. So with the increase in complexity, with the increase in distributedness, each transaction running, across a service map of hundreds of calls, the high cardinality that we have is actually causing a lot of metadata variance. And the transients, which means we are not able to identify what part of our ecosystem is up with auto scaling in place. Now, AIOps gives a big boost with respect to event correlation, anomaly detection. It also we can also talk about deterministic AI, and we'll look at a few real-time examples, right? Just before that, we spoke about data ops. The way you ingest data, the transformation of data, analysis, visualization is key. When we talk about AI ops and observability, and it talks and the quality of data. Yeah, so who owns the data, the lineage of data, the data tagging, the cleansing, all of this is very important. Data versioning, metadata storing is all important because we're going to use this data to train our machine learning models. Now, there's one more thing that's very important apart from metrics, logs, events, alerts, traces, a topology, moving, and fortunately most of the observability based platforms are moving towards topology based visualization, which is key because with all the transients and all the distributedness that we have, we should have a visualization of all the vertical stack, the infrastructure services, processes, also the horizontal dependencies, which are the incoming, outgoing call relationships. Topology is very important for us to identify the dependencies, the application map on infrastructure, containers, databases. So while observability solutions provide auto discovery of new environment components, it becomes highly critical to also look at how this topology has changed over time and how to track these changes over time. Yeah, so this is quite important when we are talking about making a jump to AI. Now, there are a few things that I'm going to be talking about here. It doesn't mean that everything is going to be using, for example, very, very highly sophisticated classification, forecasting, predictable models. We're talking about models that we can use for pattern recognition, let's say, for unsupervised models, which can be used for anomaly detection, right? For chatbots, so for example, natural language processing based algorithms that are readily available that we can use on our observable data to classify, to do first touch resolution, to classify if these are L1, L2 incidents, or even to classify them and group them into different application buckets. Yeah, so this is a case of using ML algorithms. We can also remove blind spots. So with dynamic changing IT landscapes, we can actually look at how we can use auto discovery features from ML algorithms. We could not just pass the context and the information when we are doing intelligent routing to SREs. We can also actually provide complete information of what will be useful for speedy resolution, right? We can also use models that will help categorize, and it will also help go through knowledge bases, and these algorithms can be built with feedback loops, so that when the SREs or when the product teams ultimately find out the root cause, they are actually reinforced into the model so that these models become better and better, right? So this is a classical example. It's an example. So where we are able to correlate metrics and events and identify anomalies. So in this web app, if there is an application, and if this application is made up of number of services, we are able to use machine learning capabilities to identify which service in particular has caused this problem, right? Where is this anomaly? So this is indicating that there is service 1 which has got an anomaly. Further dependencies on service 2 and service 3 are also exhibiting anomalies. And this automatic root cause detection including on all the vertical stacks and also on the horizontal dependencies, is going to be a wealth of information. Even if it is not going to be, we're not talking about auto remediation here, but even when it goes to manual remediation, it is going to be much quicker to remediate, because it already indicates that in this particular case the root cause is actually probably a CPU saturation on one of the hosts. Yeah, so this is like the fault tree analysis or root cause analysis that can be actually simplified using deterministic AI. So the other use case that we want to see is about building these performance signatures and performance thresholds and having these baseline thresholds. And machine learning algorithms can actually identify and find the deviation from these thresholds, right? And they can dynamically calculate baseline performance and provide alerts when there are deviations. So in this particular example, so if there are deployments that are happening, let's say 2 times a day, right? So you can run these performance signatures twice a day, just after whenever you have these deployment windows. And then you can automatically identify if there are major deviations, and this information can be fed back to the developers through auto alerts. Yeah, so this will help in capacity planning and optimization, and we can now actually use regression models here to build on historical data. So there are a few things that we can use, right, to feed information into these models. So apart from the metrics and events and logs and the topology information, we can also feed root cause analysis from previous incidents into these models, and these models can actually also take information from let's say not just structured data like which is from Kubernetes. It could take chat information for example, from Slack. You can also take information from ServiceNow. So you can start with a model which is not highly sophisticated, but you can just keep building and reinforcing the model to make it more and more accurate, right? So this is an example. So the other example is, again, when we talk about auto remediation, so this is an oxymoron. In a sense, we just covered, a couple of slides back, how transient the entire system is, how fragile it is, how how there are so many moving parts. And when there are so many moving parts, we are not talking about steady state, right? So if there is a steady state, it is possible to come up with every single scenario and auto remediate. When we are not in a steady state, we are not talking about having all the nines in our reliability metric, in our SLO. We're talking about remediating as much as possible. Because if you're going to look at all the corner scenarios and build all the nines, then we are talking about a lot of, it may not be economically feasible, right? So start with such use cases. Yeah. So let's add service instances. If you're talking about an on-prem solution here, have some simple models which does a performance baseline check, and you're able to add services, you're able to restart services, you're able to adjust memory settings, switch back to green. If these auto remediation steps do not work, then put a lot of information, build whatever information that you can, and pass it on to humans who can probably then initiate rollback. So here it's going to be very quick for them to actually, because they have got a lot of information, it's going to be very quick for them to auto remediate, right? So these are some classical auto remediation steps that we can use ML models for. So for example, in this case, there is a crash, and we can use ML models. We can if there is disk cleanup that is required, then we can use some scripts and automation scripts here. So there we are not talking about huge, big, large fleet of data scientists sitting and working on observability data. We're talking about how do you slowly build your capability using machine learning algorithms, right? So there are a few more use cases here. Anomaly detection we saw. So this can be simple models which are available off the shelf you can use, and it's going to detect anomalies, and it's going to generate insightful alerts. We could use predictability analytics here. We're talking about taking data from DevSecOps pipeline. So the typical SDLC lifecycle, design, code, build, test, deploy. So in this, if we are able to snowball the information right from when there are commits into the GitHub to right across, probably testing. So what kind of test coverage did we have? What kind of code vulnerabilities? How good is the code report? So we keep feed forwarding this, and also deployment descriptors that would come along the DevSecOps pipeline. Then we are able to predict, and we are able to associate a risk with every deployment that comes through a DevSecOps pipeline, right? So this is the feed forward that we talk about, and we are able to predict the impact. We can predict if your deployment is going to have issues based on past incident, based on all the data that has been snowballed and collected across the DevSecOps pipeline. So we can also use AI to correlate disparate performance data and to pinpoint performance issues that will facilitate root cause analysis. It can also be used for suggesting from your knowledge base resolution. So it could be a resolution guide that your ML model can predict, right? So again, going back to Gartner, so anomaly detection, performance analysis, correlation, contextualization data, So throwing all this data into a big data kind of a platform and putting machine learning algorithms is going to help you expedite the mean time to detect. It's going to expedite intelligence. It's going to, build through reinforced learning. It's going to build your capability to bring up your systems and make them very, very, very resilient. Yeah, so that is what we are talking about, machine learning capabilities and AI ops. And we are talking about why without AI ops you will have limited amount of capabilities, or you will be putting resources in line with the growth on data, growth on your system landscape, which is against the principles of SRE. Yeah, so SRE is about not is having very non-linear growth in your resources and in your capacity and your capabilities with respect to your business growth. Yeah, so we are talking about bringing in core SRE principles here when we talk about machine learning and AI ops being used on observability. So quickly here, on a DevSecOps pipeline, again, using observability data. If anomalies are detected, root cause analysis is done, we are able to find out what has happened on an incident. So we can use this to feed back to our SDLC pipeline, to build intelligence into how we have coded. Once we find the root cause, it doesn't make sense if we do not feed this data completely back into the life cycle, right? So if there was an issue with provisioning, if there was an issue with our deployment scripts, if there was an issue because the test coverage, there was a authentication issue, and if it was a corner test case that was not covered, so how do you really feed it back into the quality gate of improving test coverage? Or if there was a distributed tracing, a memory leak that has occurred, then how do you really build it into the build and the code quality gate, right? So this is the feedback that we are talking about, which builds a much stronger DevSecOps pipeline. So it is two ways. So the data that goes from the DevSecOps pipeline into our machine learning models will help reinforce the machine learning model's capabilities to become more and more intelligent, and the feedback loop from incidents that have happened back into the DevSecOps pipeline, right? So these are really quite useful in helping us build very, very high resilient systems. And without ML, again, without ML ops, without capabilities that we derive from machine learning, it's going to be quite tiresome, very time consuming, and effort intensive. So this is, again, we need to focus on business value metrics. So this is a use case where this particular team kept a very strong focus on response times, and they looked at uh, very, very close page loading metrics. For example, first meaningful paint, right? And this was built, these metrics were built right into DevSecOps pipeline. So with every commit, it was not even coming to, when there were these lighthouse metrics, or when the testing of the new code happened, it would not even pass the quality gate of DevSecOps. So this is the end user scenarios must be kept in mind. So the number of users and interactions, and when we do the performance baseline, it has to be based on load, it has to be based on peaks and troughs, and it has to be based on the real life scenarios, right? So this is just to reiterate that we need to focus on business value metrics. So, and then we add the key metrics from the incidents to quality gates, so that we cover the entire software development lifecycle. So there is this feed forward loop, and then there is this feedback loop from the machine learning algorithms back into DevSecOps. So this is how we automate resiliency into the DevSecOps pipeline and resiliency into the systems ecosystem. Just to wind up, so it's about building resiliency into our systems, into our ecosystems, and it is about actually keeping a firm focus on customer metrics, and it is about crashing the MTTR, the MTTD and the MTTR, actually, to an extent that if we can actually predict anomaly detection, then you would still have an MTTR, which is after the incident has occurred. But if you are able to use advanced ML and AI techniques that I spoke about, which is using probably forecasting and predictability algorithms, and if you are using good quality data from metric logs, even not to forget topology, not to forget intelligence that has come from root cause analysis of previous incidents, not to forget all the data that we have captured from our DevSecOps pipeline. If we can feed these into our machine learning algorithms, and if we can start small but we really fine tune and make them perfect, then we will be able to actually go into the prescriptive world, which means we are able to proactively prevent incidents from happening. So thank you so much for your attention. So I just wanted to demystify how AIOps really helps us to build more resiliency when on observable data. So we're not talking about the biggest of the models and the most complicated, that there's just an example here. We're not talking about such models which will really take just text and convert it into a video. We're not talking about such big stuff. We're talking about start small, start with small target areas, reinforce your machine learning models, and experience practically the advantages of having machine learning on observable data. Thank you so much for watching. I will be available for taking questions, and have a good rest of the day. Thank you.